Hey, good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at November 2024 question paper. All right, so yeah, we're going to start with question one, statistics. So it says at the beginning of a season, so the coach of a junior boys rugby team recorded the weight in kilograms of the 15 players in his team and the number of push-ups that each player was able to do in 1 minute. Okay. The data is represented in the table and scatter plot below. The least square regression line for the data is shown. Okay, so we have what the data represented as a table. We also have a scatter plot thereof. Remember, scatter plot is just those points being plotted thereof. And then we have a what is least square regression line of the best fit. Okay, yes, beautiful. Everything is there for us. Well, I'd be happy if an examiner gives me a task to draw this thing because it's just easy marks, but it's fine. Let's just do interpretation because yeah. So basically it says if you weigh this one, you have to do this number of push-up. If you weigh this one, number of push-up, whatever. Let's see. Now let's answer the question. Determine the equation of the least square regression line for the data. We know how to get data using our calculators. So when we use our calculators, we get that our least square regression line is going to be, okay, 89.46 plus minus 0. Let me write it somewhere. Okay. 89.46 minus 0.59 x. For just easy 3 marks. For that fella, you get 3 marks. Answer only, you get 3 marks because you have used your calculator. And then they say write down the correlation coefficient. We know how to get correlation coefficient. R is going to be equal to how much? It gives me something like negative 0.8 because obviously it is negative. Why? Because it is like that backwards. Okay. I assume everyone knows how to use the calculator to get these things. So hence, I'm not emphasizing that one as much so that we can move fast and move at the questions that needs now a concept thereof. They say the coach uses the least square regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a member of a team who weighs 28 kilograms should do to meet the target. Basically, they are saying to you, we're going to be using this equation, okay, which is the least square regression line, to find the number. Remember the y. Remember the y, it is the number of push-ups that you do. So we will be using this equation to see if now you weigh this much. If you weigh this much, how many push-ups you are supposed to do. Okay, so they say predict the number of push-ups that each member, that a member of the team who weighs 29 kg. Okay, so remember the kg are what are the weight, the x. So what I'm gonna do, I'm gonna substitute x as 29 to see how much this particular person is expected to do. Like 89.46 minus 0.59 multiplied by 29. And then you get something like 22.35. 22.35 push-ups. Again, you can say it is 22 or 23, but just leave it like this. It's fine. It's fine. Okay, yes. And then they say, write down, write down, write down, write down the mean number of push-ups for the given data. Let's see mean number of push-ups. Can you see mean number of push-ups? You already have your data in your calculator where you have plotted this part. Again, you have already plotted this one on your calculator, the x as this one, and then the y as that one. Then what I want you to do, it is for you to go to your calculator and press shift stat, okay, which is number one, and then choose this one that says Do not choose regression line. No, because they are wanting the mean. Choose 1 minus VAR and then choose, there is this one that says Y bar. Okay, we have X bar, we have Y bar. So X bar, it is the mean for the weight, and then the Y bar, it is the mean for the push up. So if you choose that Y bar the off, you get that it is. Or what you can do, you can add all these numbers the off and divide them by 15. Then you get a mean of something like Y bar of something like 18.33. Okay, yes. And then they say to you, the player, okay, so the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they let me repeat that. The coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. Okay, so how much increase is the number of push-ups? Okay, how does the increase in the number of push-ups influence the standard deviation of the data? Well, the standard deviation refers to how scattered your points are, or in simple terms, it refers to how far are your points from the mean. Let's say I have a mean here, and then I have a point, I have a point. Let me do this. I have a point, I have a point here, I have a point there. Okay? These are my, let me do this mean. These are my scatter plots, okay? And then let's say here it is 2 here, and then the maximum it is 10, and then our mean it is located somewhere at 4. Then the original one, it is here. And then they tell you that at the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. So if they did 5 more push-ups, it means now each and every point on my graph will move by 10. So by 5. Each and every point on my graph will move by 5. Will move by 5. By 5. So it means now my new points will be somewhere here. Then this will be my mean somewhere here. This would be my point here, my point somewhere here. And then what I want you to realize is that if you were to check the distance from this one to this one, and this distance from the new one, like this, the distance will be the same. Why? Because now it's like our graph shifted. Okay, it's like we had points here, but they shifted all of them here by 5 units, and all of them they shifted with the same number. Okay, so it means now whatever the distance was between the mean the mean and whatever point, it will still be the same. Okay, maybe let's say here it was, let's talk about this one. If the distance from this one to this one was 6, can you see 10 minus 4? It means the distance from this one to this one, it will be also 6. Why? Because this point here, the mean here will now be at what? At 9. And this point here will now be at what? Plus 10, 15. Can you see now the difference between 15 and 9? It is also 6. So it means now our standard deviation, which refers to the scatter, okay, the scattering of our thingy, of our graph, how our graph is scattered basically. Okay, so can you see that when I increase these push-ups by 5, each and every player, they will now do what? It will have a what? A no influence. Okay, you can say no influence because your data will still be actually the data won't be the same, but the changes will be the same for everything, so it won't change. How does the increase in the number of push-up influence this? You will say no influence, or you can say remains the same. They say at 1.6 at the beginning of the season, né? The coach used the least square regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of target, or so number of push-ups that a team member must obtain to reach the minimum. So, okay, let me break down this. They're saying that at the beginning of the season, the coach used the least square regression line as the minimum target. Remember, the coach used this one as a what? As a minimum target. That what? Let me zoom out. That when you have 30 kg, the coach uses this line to get the to predict your weight. Okay, so the coach says when you have 30 kg, what I'm expecting you to be doing, it is something close to 22 push-ups. Okay, when you have 50 kg, I'm expecting you to be doing this much push-ups, 10 push-ups. But now the question says determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. So they're basically asking us which which of these players, can you see these points are the players? Okay, which of this data here is too far away from the what? From the least square regression line. Which one is too far from the least square regression line? Because such that, can you see what they're asking us? Determine the maximum possible increase in the number of push-ups that a team member must obtain to do what? To reach a minimum target. So if I check this one, let's check this player here. This player here. This player here had let's say 22, 24, 26, 28 kg here, right? And the number of push-ups expected from that player was something like here maybe boma 20, 23, ne? But can you see that the player did more than that, right? So it's fine. So we want to see which one recorded the lowest, more than. Okay, which one recorded less push-ups than the predicted one? Okay, if you check here, this one is not okay, it's far, not that far, not that far, not that far. These ones are above. I won't even consider them. I won't even consider these ones. They are above the expectation, so they are good. They are doing extra mile. But can you see the ones that are below? This one, it is the furthest. So this one, it is the maximum increase. This one, also these ones need to improve. These ones, they need to improve. They need to improve because they are below the minimum target. Can you see? But now, which one can have a maximum increase so that now they meet the target? Can you see? This one is the one that has a what? That needs a what? A minimum, a what? Maximum rather, sorry, a maximum increase. Because can you see from here to here, maybe he needs 3 push-ups, or yes, this one needs 4 push-ups, this one two, this one one. But this one needs a lot of push-ups to do what? To meet the requirement. So the question is asking about that particular person, Hore. Uh, Determine the maximum possible increase. Okay. So the maximum possible increase is that you have to tell us that six, this one. Let's check this one. Can you see? You'll say now, let me do this. You'll say 6 is the furthest what? Y value below the least square regression line. And then now an increase of how much is needed, an increase of how much is needed. If we're using our graph here, we expect this particular person to be doing how many push-ups? Let's check. We expected this particular person to be doing at least 16 push-ups. Can you see, guys? So we expect this particular person to be doing at least 16 push-ups, but he managed to do 6. So what is the increase thereof? What is the increase thereof? The increase thereof from 6 to 16, it is 10. Okay? So the maximum increase, it will be what? So the maximum increase in number of push-ups is 10. Let me say, therefore, therefore, 10, 10 is the 10 is the maximum increase. Okay, 10 is the maximum possible increase. In what? In number of push-ups, you know that, right? Yes. So this is basically that it wanted you to understand exactly what's happening. Let's move on to question 2. It says the cumulative frequency graph, or guys, shows the time taken in 6 minutes for 60 employees to travel to work each morning. Okay, so let me repeat that. The cumulative frequency, which is an OGIF, shows the time taken in minutes for 60 employees to travel to work each morning. Okay, guys, estimate, estimate your what here? Let me do this. Estimate your median. Estimate the median travel time. What is the median travel time, right? How do you find the median, guys? How do you find the median? To find the median, remember the median, it is the what? The middle number, again, the middle data of. So they want the estimate the median time, travel time, okay? Median travel time, median travel time, median travel time. So how can I find the median travel time? So I need to check what is the maximum time of that a particular person can travel, okay? Oh, okay. What you need to do is, this is the cumulative frequency you're going to use to find the position, okay, of, you're going to use your cumulative frequency to find the position of the what? Of the median, okay? So for me to find the position of the median, I'm going to say the median is going to be half n. This is the position of the median. Then the median, where n it is what? Where n it is your what? Sorry, where n it is your cumulative frequency. Where n it is your cumulative frequency. So my median is going to be half multiply. What is my cumulative frequency here? Can you see? It is 6 again, the highest. Actually, the latest, the number of what? Or the number of employees here. These are the number of employees. So I need to check the cumulative frequency is supposed to be 60 thereof, and then the position it is state. This is the position. Position. Actually, let me check the position. This is the position. And then I go to date here. Let me zoom that for us. Let me use a smaller nyana thing so that our data will be more accurate. How about this one? Okay. So 30 it is here. I'm gonna move along that line. 30. Immediately when it touches my graph, I move downwards. Okay. So this is that, guys. Let's check by what interval is that happening there of. Let's see. From 60 to 80, let's see, it might be 62, 64, 66, 68, 70, 72, 74, 76. Yeah? 62, 64, 66, 68, 70, 72, 74, 76, 78, 8. Okay. So the interval is by 2, by 2, by 2. Okay. So here now I get 70, 62, 64, 66. So I get the median to be something like 66. Let's check. Yeah, more or less 66, 65. Okay. So now I get my median. This is the median thereof. This is the median thereof. Let me note it down here and say, this is my median. This is my median to be 66. Okay, my median to be 66. The approximation. So I'm gonna say the median, I'm gonna have a range from, I'm gonna say the median, it ranges from, I'll say it ranges from 65 to 66. Any answer between these two. it's gonna be fine. But then I'll use 66. Okay. And then they say to us, estimate the lower quartile. Remember, in a data, we have a higher quartile, a lower quartile, and a median. Minimum, quartile one, which is the lower quartile, median, quartile three, higher quartile, and maximum. So lower quartile, it is quartile three. How do I find quartile three, guys? If I have a data, quartile one, median, quartile, Mpumaka. I'm lying. It's supposed to be what? How? I've forgotten how. What are those things? Let me see. Uh, okay, quartile one, quartile two to three, blah, blah, blah. Okay, guys, but to find the position for quartile one, which is the lower quartile, it is one. For quartile one position, actually, let me do it here. The position for quartile one, is going to be 1 divided by 4 and then multiply by n. 1 divided by 4 multiplied by 60, we get something like 15, right? So we need to locate where is 15 located thereof. We go to our graph. Let's zoom that out again. We go to our graph and zoom the what? The 15. Go along that line, reach this point, and I go downwards like that. So can you see that my quartile one here, I get something like 44. Because I said the division it is what? 2 again. So it is 42, 44. Thereof, and I get 44. I'm going to say, let me say here, it is 66. Here it is 44. And then, if they wanted quartile 3, higher quartile, upper quartile, you'd say 3 divided by 4, the position, and then multiply by 60 and find it. Estimate the interquartile range. How do you find the interquartile range, guys? How do you find the interquartile range? Remember the formula for interquartile range? It is Q3 minus Q1. What is Q3? We do not know. Minus Q1 we have. So we need to find quartile 3. Can you see? And position for quartile 3, it is 3 divided by 4. Multiply by what? By 60. Therefore, it will be something like 45. Okay, so the position, actually, this is the position for quartile thingy thereof. Then let's go to 45 and estimate that. We estimate that to be something like 44, 84. So I estimate this quartile 3 to be something like 80, 84. I hope that's clear for everyone. 82, 84. Okay, yes. So now I can beautifully say, okay, it means therefore it is how much? 84 minus 44, which is basically just what? 40. Okay, you needed first to calculate the what? Your quartile 3 again, and then calculating the off. It is another beautiful mark. And then they say the minimum and maximum time taken for an employer to travel to work are 5 and 120 minutes respectively. So the minimum and maximum times, it's either you go to work by in less than, okay, in 5 minutes, which is the minimum, or the maximum that a person can get, it is 120 minutes to go to work, which is basically 2 hours. And then they say on the scaled line in the answer book, draw a box and whisker diagram to indicate the distribution of the data as represented in the archive. Remember, for you to draw this is the graph they were talking about. For you to draw a box and whisker plot, you need a what? Maximum value, quartile 1, median, quartile 3, minimum value, sorry guys, minimum quartile 1, median, quartile 3, maximum. So the minimum they told me it is 5. Okay, 5 is somewhere located here. I'm not sure whether to use a ruler or what. Okay, let me, it's fine. Quartile 1, 5, it is located here. And then my quartile one, it is 44. If this is 45, somewhere here, somewhere here, somewhere here, somewhere here, 44. Okay, I like to do the dots, all of the dots. And then what is this? Median was something like 66, 65, 66, 65. I'll use 66. Or let me use 65. Ne? This is 44. You all know this is 5. And then let me use 65 here. It's going to be fine. Or let me just use my 66. And then my quartile 3, there was 84. Somewhere there, 84 again. Before 85. And then, okay, I think this one is too far. Okay. And then my maximum it is 120. So remember when you do or what box and whisker plot is supposed to be something like this. Again, this is what we refer to as the box and whisker plot. So what I'm gonna do is on these ones, I'm gonna do a lines like this. Okay, lines like that across them, and then like that. It might be skew, but when you'll be using your rule again in an exam, I can remove those if I want to. Okay, so this is what I'll draw, and then you need to join these ones here. Okay, in a very, very beautiful straight line, guys. Mine is not, and I doubt it will. So, so yeah, this is basically that, guys. You can do this and do that, guys. It's fine. This is how we refer to as a box and whisker plot. Okay, yes. And then if they were to ask you talk about the skewness of the data, the skewness of the data is that can you see that most of the part is on the left hand side? So you'll say it is skewed to the left, skewed to the left. Can you see most of the part is on the left hand side, skewed to the left or negatively skewed? Let's move on. The company manager decided to, where is it? Okay. The company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. Okay. What percentage of the employees will be allowed to work from home for part of the day? So they say the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. What percentage of the employees will be allowed to work from home for part of the day? So let's look at employees who are traveling more than an hour. Okay. So the employees who are traveling more than an hour, you can see, let me use this one. You can see who are traveling an hour, Batum, who are traveling an hour or more, for an hour or more. So an hour it is 60 minutes, right? So I'll come here, go up, go up, go up, go up, go up, go up. Or actually, so I go up until I reach my thing, my graph, the off. Okay. And then I get that those people are, how many people are there? Uh, Let me see here. Let's go. So basically, 26. So, okay. The question is, how many people will be allowed to, what percentage of people will be allowed to work part of the time at home? So, these ones here, the people in here, in the shaded part thereof, are the ones that are traveling less than an hour to go to reach at work. Okay, these ones. But these ones here, above here, above here. These ones are the ones that are traveling an hour or more. So these ones are the ones that are gonna be doing what? That are gonna be uh working part of what at home. So how many people are there? So if there are 60 people in total, 60 people in total, and now this portion thereof, can you see they are the ones that are traveling more than an hour? Or if you want me to illustrate it beautifully, I'd say these ones here. Okay, so these ones travel less than an hour. From here to there, they travel more than an hour. From here to there, they travel more than an hour. So how many people are there? So it's going to be 60 minus 26, which is 34. So 34 people are traveling more than an hour. But the question is, uh, what percentage of the employees will be allowed to work from home for part of the day if they travel more than an hour? So we know that 34 people out of 60 people are the ones that are traveling home by an hour here. Therefore, you multiply that by how much? By 100. And then you get something like 56.67% of the employees. I hope that's clear. I hope that's clear. Yes. And then, and then employees work 8 hours in a normal working day. The manager decided on the following rule for time to work from home. An employer is allowed to work half an hour from home for each time interval of 20 minutes or part thereof above an hour taken to travel to work. Let's repeat that statement. An employee is allowed to work half an hour. So an employee is allowed to work 30 minutes from home for each interval, 20 minutes or part thereof above an hour taken to travel to work. Basically, it means if um if you work more than an hour to work, let's say you take something like 70 uh say 70 minutes. Ne? This it is already remember it will be what 60 minutes plus 10 minutes. So you work you will get a chance of uh okay, so an employee is allowed to work half an hour from home for each interval of 20 minutes part of above an hour to travel to work. So if you travel above an hour, this is 1 hour. So for this extra time that you have to travel thereof, you are granted to work from home for what? For 30 minutes. Okay. Irrespective of whether the time it is 20 minutes or not, because they say an hour from home for each time interval of 20 minutes or part thereof. Okay, or part thereof above an hour take to travel to work, blah blah blah. So here, sorry, so here on a certain day, an employee takes 110 minutes to travel to work. Okay, calculate the number of minutes that this employer will be allowed to work from home on this day. So we agree that if this particular person travels 110 minutes, an hour it will be 60 again. 60 minutes, which will be fine, plus 20 minutes. Okay, let's check 20 minutes. This is 80 plus another 20 minutes. This is 100 plus another 10 minutes. So this particular person will get to work from home for each of these. So for the first 20 minutes, he will work he will be granted 30 minutes. For another 20 minutes, after an hour, he will be granted what? Another 30 minutes. Also here, this particular person will be granted what? A 30 minutes. It does not necessarily need to be 20 minutes or more. They said a fella interval of 20 minutes or part thereof, as long as it is above what the 60 minutes. So now it means now the answer is supposed to be what? how many intervals do we have there of where you get the time? It's gonna be now 3 multiplied by the time granted each of those time slot. It will be so 30. So now the time allowed to work at home, it will be 90 minutes. So this is 90 minutes or 1.5 hours. I hope that's fine. So yeah, that's basically that for statistics, and I hope you enjoyed. And yeah, there's nothing difficult. Let's just push.